Welcome back to the deep dive. Today we're shifting gears a little bit. Usually we take this really wide angle lens on a topic, looking at the big picture. But today we are zooming all the way in. We're getting totally microscopic.
We really are.
Yeah, and we're doing this specifically for those of you out there who are currently in the trenches of certification. We are looking at the CPM AI framework, specifically cognitive project management for AI, and we're drilling down into phase 3, which is data preparation. And look, I have to be totally honest with you right out of the gate here. I am struggling.
It's a tough one. It really is.
It is. I've been staring at phase 3 all week, just trying to wrap my head around the flow of this phase, and I feel like I keep hitting a wall. It's so dense, and I don't know, a lot of it feels like it conflicts with how I've managed projects in the past. Especially the sequencing. I keep confusing the sequencing.
That is a very, very common feeling when people hit phase 3. I mean, I've seen seasoned project managers, people with 20 years of experience, hit this exact phase and suddenly feel like they don't know anything at all.
Okay, well, that makes me feel a little bit better, at least.
It should. It's the point in the project lifecycle where things stop being theoretical. You know, all those nice business goals from phase I, they disappear, and things start getting very messy very quickly. It's really where the rubber meets the road. So what specifically is tripping you up? Is it the definitions?
It's the sequencing. That is the big one for me. Because honestly, looking at the list of tasks, cleaning data, labeling data, selecting data, it really feels like I can just do these tasks in any order. Like in my head, I'm thinking, does it really matter if I label it before I clean it, as long as the whole thing is done by Friday?
Right. It feels like you should have that flexibility.
Exactly. It feels flexible.
Yeah.
But the study guide seems to imply it's completely rigid.
Yeah.
And then there are these terms that sound identical but apparently mean totally different things for the exam. Like, I keep confusing clean data with enhanced data. In normal conversation, if I clean my car, I'm enhancing it, right?
You are. But here, they are very distinct boxes.
Right. So here's what I want to do today. I want to completely scrap our usual format. I want to treat this session like a coaching call. I'll be the candidate. I'm the one who's confused, stressed out, and just trying to pass this exam. And you are the coach. You've been there. You've passed it. You know exactly where the traps are.
I love that format. Let's do it.
Awesome, because I really want to slow down today, way down. I want to go through the hardest pairs of terms, and I want you to walk me through the specific CPMAI constraints. I want to understand the why, not just the what.
Perfect. But before we dive into the weeds of those specific terms, let's frame the phase so you and everyone listening knows where we are on the map. We can't just jump into task 3 without understanding the actual landscape.
Okay, lay it out for me.
So phase 3 is data preparation. If phase I was defining the problem, figuring out what we actually want to solve, and phase 2 was the blueprint, understanding what data we currently have, then phase 3 is where we take the raw material and turn it into fuel.
Oh, raw material to fuel. I actually really like that image. So phase I and 2 are the architectural drawings, and phase 3 is the crew actually pouring the concrete.
Exactly. And here is the most important mindset shift you need to make right now. And I mean this because this is where most candidates fail. Phase 3 is not about independent discovery. You are not an explorer in this phase. You are a builder. You are executing the specifications that were written in phase 2.
Okay, that's interesting. So I'm just following instructions. I'm not improvising or coming up with new ideas.
Precisely. In phase 2, you did the data understanding. You looked at the quality. You identified the specific gaps. Now in phase 3, you are just fixing those quality issues and filling those specific gaps. You aren't deciding new things to do. Now, structure-wise, for the exam, we are looking at 3 specific task groups in this phase.
Just 3. Okay, I can handle 3.
Yes, 3. First, we have data selection. This is high priority. Obviously, you can't prep data you haven't selected. Second, we have data cleansing and enhancement. This is also high priority. And third, we have data labeling.
And let me guess, knowing how CPMAI works, labeling is the one I really need to worry about.
You absolutely do. Flag this right now. Data labeling is marked as critical priority. For the purpose of the exam, this is where a lot of the high-stakes trick questions live. If you mess up data selection, you have a bad project. If you mess up data labeling in the context of the exam questions, you fail the section.
Critical priority. Got it. I am flagging that in my mental notebook right now.
Good. Now, here is the engagement rule for today's deep dive. I don't want you or our listener to just passively sit back and listen while I lecture. That does not work for retention at all.
No, definitely not.
Right. So I am going to give you scenarios. Real-world, messy scenarios. And before I reveal the answer, I want you to mentally pick what you think is right, commit to it. Even if you guess. That moment of choosing is where the retention actually happens.
Deal. I am completely ready to be wrong. I'm actually expecting to be wrong a lot today based on how my studying has been going all week.
That is where the learning happens. So let's start with the top terms. What is the first one you want to unpack?
Let's start with the big one, the critical priority one you just mentioned, label data. To me, this just means tagging things, right? Like,
Yeah.
I have a picture, and I tag it as a cat. I have an email, and I tag it as spam. It feels like very basic administrative work.
In plain language, yes, that is the physical act of doing it.
Yeah.
But for the exam and for the framework itself, you need a much sharper definition. Label data is a formal, named Phase 3 deliverable.
Formal, okay?
Yes. It is the process where structured annotations are applied to data so that supervised and cognitive models can actually learn. The key word there is formal. This is not a side task that an engineer does on a Friday afternoon just because they need to get it done.
So it's not just an informal nice to have. It's a formalized, mandatory gate.
Exactly. Here is your metaphor. Think of it like marking up a student's exam paper with the correct answers before you use it as a study guide for the next year's class.
Okay, I'm following.
Imagine you have a stack of completed math tests. That is your raw data. If you hand those to a new student and say, learn math from this, they won't learn anything because they don't know which answers are actually right and which are wrong. An unmarked paper is just raw data. It's totally useless for learning.
Right, they need the red pen marks.
Exactly. A marked paper where every single question has the right answer written next to it in red pen, that is a labeled data set ready for learning.
That makes perfect sense.
Yeah.
If the model doesn't have the answer key, it can't learn to pass the test. It's just guessing.
Now, I need to integrate a revision note here because there has been a recent nuance added to the study guide that trips people up. This labeling requirement applies specifically to supervised and cognitive models. If you are using unsupervised approaches like clustering, you do not require this step.
Because unsupervised means the model is just looking for patterns on its own, right?
Right.
It doesn't need me to give it the answer key.
Exactly. Unsupervised models organize the data themselves, but for supervised learning, which is a massive chunk of AI projects, you must have labels. So let's test you on this. Here is a scenario, straight from item 1, scenario B, in the materials. This is a hard scenario.
Bring it on. I'm ready.
You are at a financial services company and you are building a transaction fraud detection model. The data you have is thoroughly cleaned, it's sparkling, no duplicates, nothing missing.
Nice. That never happens in the real world.
True. Now, the team lead wants to begin phase 4, which is model training, immediately. Why? Because some of the records already have labels from a legacy system, and the lead plans to just handle the rest of the labeling during the training phase to save time. But phase 2 required full coverage. So, as the project manager, do you let them move to phase 4?
Okay, let me think this through. The data is completely clean. That's usually the biggest hurdle in these projects. Cleaning takes forever. So they've done the heavy lifting already. And they do have some labels from the legacy system. Plus, they want to keep moving fast. In the real world, speed is everything, right? If I'm that team lead, I'm thinking, let's get the model running, and I'll just have my team tag the rest of the data while the model churns on that first batch.
That is a very common thought process.
It feels agile. It feels efficient.
Yeah.
So I would say yes. If the data is clean, that's sufficient to move on. Clean data is sufficient, and they can catch up on the labeling as they go.
And you just fell into the trap. That is incorrect.
Seriously, incorrect.
Yeah.
But the data is completely clean. Why does it matter exactly when the labels happen as long as they happen?
Because of the definition we just established. If the approach requires supervised labels, a cleaned data set without complete coverage, meaning meeting the exact phase 2 requirements, is not a usable training data set. Labeled data must be completed as a formal phase 3 deliverable before phase 4 begins. You cannot overlap them like that. Think back to the metaphor. A stack of test papers that are perfectly ironed and have no wrinkles, that's clean data. But if there's no red pen on them, the students still can't study from them.
Well, okay, so clean does not equal ready.
Exactly. Here is your memory hook for this term. No labels, no learning. At least for supervised models, it is a formal task, not an informal fix.
No labels, no learning. Formal task, not an informal fix.
Okay.
Writing that down. So the trap is thinking that clean data is enough to start training, or that you can just finish labeling while the model is training. You can't.
You absolutely cannot. Ready for the second term?
I am. Hopefully I did better on this one.
The second term is clean data.
Okay, clean data. This is the one I was confusing with enhancing earlier. To me, cleaning is just fixing stuff, removing the junk from the spreadsheet.
In plain language, this task removes the errors, inconsistencies, and noise that were identified during the Phase 2 Verified Data Quality Assessment.
Oh, wait, so it's tied directly back to Phase 2 again.
Always. You aren't just cleaning randomly, you are cleaning the specific things Phase 2 told you were broken. Here's just her metaphor. Think of it like sanding a wooden surface before applying stain or varnish.
Okay, I do a little woodworking, so this works for me.
Perfect. If you stain over rough wood, what happens? The finish is ruined, it gets all blotchy. You absolutely must sand, which is the cleaning, before you finish, which is the enhancing or labeling.
Right, you can't put a nice gloss coat on a splintery table. It just highlights the splinters and looks terrible.
Precisely. Now let's see if you can apply this to a scenario. This one comes from item 2, scenario B. It's another hard one.
All right, I'm focusing. No traps this time.
A retail company is building a product recommendation model. The team completes the clean data task. They remove all the duplicates, they fix all the weird formatting errors. Now, they propose skipping the enhance and augment data task entirely because the dataset is already incredibly large in volume. They have millions and millions of rows. They argue that because the volume is so high, they don't need to augment. Do you agree with the team?
Well, this sounds really tempting. I mean, if they have millions of records, do they really need to augment it? Augmenting usually means adding more data, right? Or making the data set bigger. If they already have massive volume, big data is all about volume. If I have a mountain of data, why do I need to add a bucket of sand to it? I'm going to agree with the team. If they have enough volume, they don't need to augment. Save the time and the budget.
Incorrect again.
Oh, man. Are you kidding me? What? Volume has to count for something.
It counts for a lot, but it does not equal coverage. Phase 3 executes Phase 2 specifications. Enhance and augment isn't just about total volume, it's about coverage gaps.
Coverage gaps.
Right. If Phase 2 said that specific demographics or scenarios were underrepresented in your data, you absolutely must augment to fill those gaps, regardless of your total volume. If you have 10 million records of people buying winter coats in New York, but Phase 2 said you need to recommend clothes globally, your 10 million records don't help you with someone in Miami.
Ah, I see it now. So the trap is thinking volume equals coverage. It doesn't. You can have a massive amount of the exact same biased data.
Exactly. You must sand the whole table, and you must make sure you have enough wood to build the whole table Phase 2 asked for.
Volume does not equal coverage. That is a huge realization for me. I totally would have skipped augmentation on a massive data set.
Most people would. That brings us right into the third top term, which is enhance and augment data.
Okay, so we know it's not just about adding volume. What is the precise definition?
It expands or enriches the dataset to address those specific coverage gaps identified in Phase 2. Expanding might be taking existing data and tweaking it, like rotating images. Enriching might be bringing in outside data, like adding weather data to your sales figures.
Got it. What is the metaphor here?
Think of it like restocking a restaurant's inventory. First, you have to clear out the spoil food from the fridge. That is the clean task. Then, and only then, you order new ingredients. That is the augment task.
Because if you order new food before clearing the rot,
new food gets contaminated. Exactly.
Okay, I like that.
So keeping that in mind, listen to this scenario from item 3, scenario B. A manufacturing company is building a defect detection model using images of parts on an assembly line.
Okay, computer vision.
Right. The team begins augmenting images. They are doing rotations, changing brightness, adding synthetic overlays to generate more data, but they start doing this before completing the data cleaning step. And Phase 2 had flagged that 8% of the source images were corrupted.
Oh, boy.
So what kind of failure is this?
Well, let's look at this. They have corrupted images. 8% is a lot. And they are using those corrupted images to make more images. So they are taking bad data and multiplying it. I would call this a bad data selection failure. They picked bad data to augment.
You are so close, but in the context of the exam framework, that is incorrect. This is not a selection failure, it is a sequencing failure.
Sequencing, right, because they did it in the wrong order.
Exactly. They generated synthetic variations based on corrupted source images. Now those errors are propagated through the entire augmented dataset. You must clean before you augment. If you augment garbage, you just get more garbage.
Garbage in, multiplied garbage out.
That is your perfect memory hook right there. Garbage in, multiplied garbage out. You must sequence it correctly.
Okay, I am feeling a bit bruised, but I think I actually understand these terms now. It's not just knowing the definition, it's knowing how they interact And why the order is so strict.
That is the whole point of this framework, and that perfectly transitions us into segment 2. The top concepts. These are the underlying rules of the phase.
All right, let's do the concepts. What is concept number 1?
Concept 1 is that data labeling is CPMAI specific and high yield.
Okay, I have to stop you there. I thought I understood this, but I've done traditional project management work before. I've worked on software projects where we had to annotate data. We always do it. Why does CPMAI make such a massive deal out of this, like they invented it?
It's a great question. Most other frameworks, like Standard Agile or even CRISP-DM, they treat annotation as just an informal step that happens somewhere inside the development phase. It's just a task an engineer does. CPMAI elevates it to a named required task in phase 3.
So it's about visibility.
Exactly. Think of it like a building inspector's required sign-off. Other frameworks might treat it as a best practice, but CPMAI makes it a mandatory gate. You cannot proceed without it.
Okay, let's try a scenario for this one. I need to redeem myself.
Let's see if you can. Item 4, scenario B. A tech company is working on an email classification model. The data engineering team argues that labeling is being handled informally by the engineers as they actually configure the model over in phase 4. They tell you, hey, it worked on our previous projects, this is how we always do it, and the project sponsor, the person paying for the project, approves this approach.
Oh man, you are throwing the project sponsor at me.
I am. What do you do?
Well, look, in the real world, if it worked before and the team is comfortable with it, and most importantly, the project sponsor approves it, it's acceptable. You don't fight the sponsor on a process technicality if it's going to slow things down.
Yeah.
So I'd say this is fine.
And once again, you have been trapped.
Incorrect. Even with the sponsor's approval.
Yes. Prior success under a totally different framework does not satisfy CPMAI. CPMAI requires a formal labeled data deliverable in phase 3. Informal annotation is the exact failure mode this concept is testing you on.
Wow. Okay, so the discrimination logic here is CPMAI versus standard project management?
Exactly. In CPMAI, labeling is its own distinct box that you absolutely have to check. Concept A is standard PM, where it's informal. Concept B is CPMAI, where it is formal. Never mix them.
Okay, formal box to check. Got it. What is concept 2?
Concept 2, preparation executes what phase 2 specified.
Okay, but what if I see a way to make the data better while I'm in phase 3? Shouldn't I just do it? I want to deliver the best product possible.
No. Phase 3 has zero independent discovery mandate. You execute the blueprints. Think of a construction crew executing an architect's blueprints. They don't just decide to redesign the foundation while they are pouring the concrete, no matter how smart they think their new design is.
But surely, if it adds value.
Let's look at a scenario. Item 5, scenario B. A telecom company is building a customer churn model to see who is going to cancel their service. During the labeling task, the team decides to add a brand new churn category called voluntary signal suspension.
Like people going to a summer home or something.
Right. It wasn't in the phase 2 requirements, but the team sees it in the data, they think it's highly relevant, so they just implement it without asking.
I mean, that sounds like a really smart improvement. It's a labeling decision. They're looking right at the data, so it belongs in the labeling task. I'd support the team on this.
Incorrect.
Still, even if it makes the model better.
Yes. Because this is a scope change. Label data executes against phase 2 cognitive data requirements. Adding a new category requires iterating back to phase 2 for formal governance approval. You simply cannot make unilateral scope decisions in phase 3.
Okay, so let me restate that. Phase 3 does the work, but phase 2 makes the rules.
That is a perfect contrast summary.
Yeah.
Phase 3 does the work, phase 2 makes the rules, never mix them. Now, concept 3, sequence matters. Select, then clean, then enhance, then label.
I still struggle with this. I keep seeing exam questions about doing things in parallel to save time. In the real world, we parallel path things constantly.
While it's not a mandatory law of the physical universe, CPMAI heavily recommends the specific dependency chain because of the massive risks of doing it out of order. Think about processing a photo in a darkroom.
Oh.
You select the negative, you develop it, which is cleaning, you enlarge it, which is enhancing, and then you finish it, which is labeling. Putting the finish on before developing creates a complete mess. Let's look at item 6, scenario B.
All right, lay it on me.
An energy company is building an equipment failure prediction model. The team selects the data, and then they immediately label the failure events. Then, after labeling, they clean the data. During cleaning, they find they have to delete 340 records that were completely corrupted, but those records were already labeled.
Oh, I see it. They spent time and money labeling records that they were just going to throw away anyway.
Exactly.
So is this a labeling quality failure?
Incorrect.
Yeah?
The labels might have been perfect. This is a sequencing failure.
Because labeling preceded cleaning. They wasted the budget.
Precisely. Clean first to save the data. Label last to save the budget.
Clean first to save the data, label last to save the budget. That actually makes total sense when you put dollars and cents to it.
It does. Now, let's see how much you've retained. It is time for the rapid fire segment.
Oh boy, okay. Let's do it.
4 short scenarios. 1 sentence answers only. I will tell you if you are correct, close, or wrong. Here we go. Rapid fire 1 from item 1, scenario A. A logistics company project manager proposes skipping formal labeling and letting engineers annotate informally in phase 3 to save time.
Wrong. That violates CPMAI structure because labeling must be a formal phase 3 task.
Correct. Rapid fire 2, item 2, scenario A, healthcare company. The team proceeds to enhance and augment before cleaning duplicates and formatting issues.
Wrong. Enhancing unclean data builds on a flawed foundation, so you have to clean first.
Correct. You multiply the garbage. Rapid fire 3, item 5, scenario A, banking sector. The team finds a new external data source in phase 3, and they add it immediately without going back to phase 2.
Wrong. That is scope creep, and they must return to phase 2.
Correct. Preparation only executes phase 2 specs. Last one, rapid fire 4, item 6, scenario A, government agency. The PM wants to run label data and clean data in parallel on the same data set.
Wrong again. High risk because you will end up labeling garbage data that gets cleaned out later.
Correct. You nailed the rapid fire.
Wow. Okay, I actually feel like I understand this now.
Good. So summarize it for me. What were your big aha moments today?
Okay, the biggest shift for me. I used to think augmenting was totally optional if we had a lot of data.
Yeah.
I thought volume was enough. But now I know it's about coverage, not volume.
Yes.
And second, I used to think I could just fix scope issues on the fly in phase 3 if I saw a good opportunity. But now I know phase 3 is strictly execution of phase 2's blueprints. No improvising.
Perfect. Here is your final memory anchor for today. The most exam-critical item in this entire phase is the dependency chain. Select, then clean, then enhance, then label. Burn that order into your mind. If you break it, you propagate errors or you waste money.
Select, clean, enhance, label. I will not forget that.
And remember, for the exam, pick your answer before the reveal every time.
Thanks for the coaching. We will catch you all on the next deep dive.